This is a GCSE chemistry tutorial on the transition metals and rusting. Both of these are triple science only topics. In this tutorial video, we will first look over the transition metals before looking at the process of rusting. So what are the transition metals? Well, unsurprisingly, they are all metals. They're found in the middle of the periodic table. They all form coloured compounds. They're all very good conductors of heat and electricity. They are all much less reactive than the alkali metals. They almost all have very high melting points, except for mercury, which is a liquid at room temperature, and gallium, which melts at about 30 degrees Celsius. You can melt it in your hand. They tend to be very hard and tough, and they have high densities. All of the transition metals are capable of forming more than one ion. So, unlike the group 1 metals, where they all form a 1+ ion, the transition metals can form a range of ions. This is something that we look at in much more detail at A-level chemistry. But for example, vanadium can form a 2+, a 3+, a 4+, or a 5+ ion. This gives it a range of different coloured compounds. The transition metals include lots of metals that you'll have come across before in your day-to-day lives. For example, copper, which is used for pipes, silver, which is used for jewellery, and we've got titanium here seen as a hip joint. But a lot of those traditional metals, if we think of a metal, the sort of properties that we think about it having, are all found in the transition block. As previously mentioned, they can also form a wide range of coloured compounds. They are also able to go through corrosion, for example here with the Statue of Liberty. The Statue of Liberty would originally have been a nice copper colour. Over time the copper has gone through corrosion, and as such it has oxidised to form copper oxide, which is this traditional pale green-blue colour. Several of the processes that we will look at in other videos use different transition metals as catalysts. For example, platinum can be used in catalytic converters that you would find in a car, and nickel can be used to convert plant oils to margarine in hydrogenation. One of the most popular questions that the exam boards for both Edexcel and AQA like to use for the transition metals is the one on the screen at the moment, to compare and contrast the group 1 metals and the transition metals. I want you to pause the video now and attempt this question. We can easily compare the group 1 metals and the transition metals. Both of them form ionic compounds on reactions with non-metals, and they're both very good thermal and electrical conductors. However, the group 1 metals, as we looked at in a previous video, have low melting points. The transition metals tend to have very high melting points. The group 1 metals are very reactive, the transition metals are not. However, the transition metals can be used as catalysts. The group 1 compounds are white, the transition ones are coloured. Group 1 metals are soft, transition metals are very hard. Group 1 metals have low density and some of them float on water. The transition metals are very low density and do not float on water. The group 1 metals will react with water to form an alkaline solution, a hydroxide, as well as our hydrogen H2 gas. And finally, the group 1 metals can form 1+ ions, whereas the transition metals form various different ions. As mentioned previously in this video, the Statue of Liberty would have looked very different when it was originally erected in 1886. It would have had this copper colour. It is important to note that this is a recoloured photograph and not a photograph from the time. However, over time, this copper has oxidised to form copper oxide, which has that light green-blue colour that the Statue of Liberty has today. This process of oxidation affects all metals. However, one specific metal, which is iron, goes through a process known as rusting. We will look at the effect that oxidation can have on metals, including the transition metals. We will have a look at how we can affect the speed of rusting, and we'll have a look at how we can prevent rusting. As you will have looked at in redox reactions, metals can be both oxidized or reduced. Oxidation, in this case, is the addition of oxygen to a metal. Because oxygen is very reactive, it can easily attack metals. The metals form an oxide, being a mixture of both the oxygen and the metal. The most common of these is iron oxide. When iron becomes oxidized to form iron oxide, it goes through the process of rusting. A common test to look at rusting is to set up 4 test tubes as shown. The first test tube contains an iron nail, as well as boiled water and an oil layer. The second test tube has an iron nail with salt water, the third an iron nail just in air, and finally an iron nail with calcium chloride and a bung. We then leave these for 10 to 15 minutes and observe the difference that has occurred. We need to leave it because oxidation is a slow process, especially in terms of the rusting of iron. In this experiment, the air and calcium chloride nail will have rusted the least. This is because the calcium chloride absorbs any water that is in the air. Secondly, we will have the boiled water and oil layer, the oil preventing the oxygen from getting in. However, even when boiled, there may well still be some oxygen left in the water. Thirdly, we have the air, which has access to both oxygen and water. And finally, we have the salt water, where the salt increases the rate of oxidation. In order for rusting to occur, we need both oxygen and water. And we have iron and water and oxygen gives us hydrated iron 3 oxide. It is iron 3, the 3+ ion, that undergoes the oxidation. In order to prevent rust, we can do a few different things. First of all, we can coat the metal. This means that we would paint it, or we could use oil or grease. We do this in order to prevent water and or oxygen from reaching the iron. Paint can be used in order to create a barrier which prevents oxygen from reaching the metal. Oil and grease can be used as this prevents water from reaching the metal. As you should know, a mixture of water and oil will separate out into the 2 fractions, as oil is immiscible in water. A better method is to use galvanizing. Galvanizing is when the iron is coated with a thin layer of zinc. The zinc then prevents both water and oxygen from reaching the metal. However, the zinc will eventually wear out as we are using it as a sacrificial metal. Using zinc in this way uses a method known as sacrificial protection. Looking at the reactivity series, zinc is more reactive than iron, so it is oxidized in preference to the iron. It's going to be oxidized first. We could also use any other metal above iron as our sacrificial metal. Because the sacrificial metal is being oxidized, this means the iron is not being oxidized and therefore does not undergo rusting. From this short tutorial video, we have looked over transition metals and rusting / the oxidation of transition metals. What I want you to do is attempt the 2 questions currently on the screen. The first one is the big question for this topic, which is describe how iron is a typical transition metal, referring to its properties including density, melting point and catalytic activity. Once you have done that, I also want you to attempt the challenge question. For this one, a statue has been built out of iron. Explain how the statue could be prevented from rusting, referring to at least 2 different methods. I want you to pause the video and attempt the questions now. Looking at the mark scheme for these two questions, for that first one, looking at how iron is a typical transition metal, it firstly is an element which forms one or more stable ions. It has a high melting point and a high density. It is also able to form coloured compounds. It can also be used as a catalyst in order to speed up reactions. For iron, it is used in the Haber process. For the challenge question, the statue that has been built out of iron, we need to look at how we could prevent it. So first of all, metals corrode due to oxidation. Both water and oxygen must be present for rusting to occur. The first way is that we could exclude oxygen using paint as a barrier to prevent the oxygen from reaching the metal. Secondly, we can exclude water using oil or grease to prevent oil from reaching the metal. We can also use sacrificial protection. So this is where we use a more reactive metal that will be preferentially oxidized, for example, aluminium or zinc. In this case, the metal corrodes, but the iron doesn't. We can also coat the iron with a thin layer of zinc in a process known as galvanizing. This finishes the GCSE chemistry series on the periodic table. For further videos, please look at the playlist attached.